7.3 is logarithms, and logarithms is kind of a tough word. Makes you think this is going to be a hard lesson. It's probably not going to be as hard to do as it sounds. But logarithms has to do with exponentials. And when we solve an equation, let's say I give you an equation like 2x plus 3 equals 11 or something. You already know how to solve an equation by undoing operations. So you have to undo the plus 3 with a minus 3. And then you have to undo this times 2 right here with a divide by 2 to get your solution to that equation. Now, what does that have to do with a logarithm? Well, a logarithm is something that will undo an exponential. So at some point, we're going to learn how to solve an equation that says 2 to the x power equals something, all right? And in yesterday's lesson, we might have said 2 to the x equals 16. And so the easiest way to do that yesterday was to change the 16 into 2 to the 4th power. And so if you have 2 to the x equals 2 to the 4th, you can see that x equals 4. But at some point, we're going to get 2 to the x equals 15, and you're not going to be able to solve that problem the same way. You won't be able to make a 15 match with a 2, and you won't be able to do what we did in the last lesson. All right, so a logarithm is going to help us solve this kind of problem, solve this kind of equation. It's going to undo an exponential. Exponential is when you have a variable in the exponent. So it's going to help us to solve. But the short story of it is, I want you to remember something. I want you to memorize that a logarithm equals the exponent. So write that down, remember that. That's going to help you out a lot, I think, on these problems. A logarithm equals the exponent. So a logarithm has to do with exponential. They kind of go together like multiply and divide, or like add and subtract. They go together. Problem 1 says rewrite each equation in exponential form. So notice they give us a log, but they want exponential. Again, exponential means you've got a variable in the exponent or something in the exponent, usually. All right, so we want an exponent. So remember what I told you to memorize. A logarithm equals the exponent. So let's talk about an exponential real quick. When we talk about an exponential, this number is the base. And of course, this number right here is the exponent. We've got a base and an exponent. And I kind of relate it to like cheerleading. When you've got like cheerleaders and they're making a pyramid, you've got the base cheerleader is holding up usually the little itty bitty one up on the top, and that's kind of what I see right here. You've got a base cheerleader holding up a itty bitty little cheerleader at the top, making a pyramid. All right, but you've got the base and you've got the exponent. So how you read a logarithm, you read this problem as log base 2 of 64 equals 6. All right, so that's how you read it. Log base 2 of 64 equals 6. And you don't necessarily need to write that down, but that's how you read it. Log base 2 of 64 equals 6. So you notice how I literally said base 2? That's the base of my exponential. All right, so this 2 right here is the base that's going to be holding up the itty bitty little exponent. All right, now you've memorized that a log equals the exponent. That means that this thing right here, the 6, is the exponent. 6 is the exponent. 2 to the 6th. There's a base 2, there's an exponent 6, and if you think about it, 2 to the 6th literally equals the other number, 64. That's the answer. That's all there is to it. We just changed a logarithm into an exponential. So then if you look at number 3, the base number is this 7. And since a log equals an exponent, 2 is the exponent, we've got 7 squared equals the other number, 49. That's what we do over and over and over again. So number 5, again, I want to remind you how to read this. If I was reading it, I would say log base 12 of 12 equals 1. That's how you read it. But we are translating this to exponential form. And so we have a base, this is the base. A log equals the exponent, so that's the exponent. And it's going to equal the other number, this number. 12 to the first equals 12. That's your exponential. So then number 7, what's the base on number 7? Anybody tell me? 14. What's the exponent? 0. And sure enough, 14 to the 0 power, if you plug that in on a calculator or whatever, you should know that equals 1. Now problem number 9, we're going the other way. This time, we start with an exponential equation, and we want to write it as a logarithm. All right? So it's the same kind of questions that I ask myself. I ask myself, what is the base and what is the exponent? If you can determine the base and the exponent, then you should be pretty good. So in this problem, the base is the number that's holding up the itty bitty little exponent. Okay? So that's the base. I know this answer is going to say log base 19. So write it as a subscript. Subscript means it's small and it's a little bit lower. Subscript. And I know since I've memorized that a logarithm equals an exponent, that means that this exponent 2 is what the log is equal. Log base 19 of 361 equals 2. Now, when I've taught this in the past, sometimes students have a hard time of sizing up the numbers. The little bitty 19, that's a little bitty number, that's a subscript. But the 361 is the same size as the L in log. So all of your numbers are pretty much the same size. Imagine, I don't know if you guys did, but when I was in kindergarten, we had this kind of paper, and we had to learn how to write on paper that looked kind of like a highway. And so did you guys have this kind of paper too? Or is it just me back in the olden days? So if I was going to write this, the L and the O and the G, and then there'd be a base 19 is going to be little bitty right there. And then the 3, 6, 1. So pretty much all of those letters and numbers are the same size, except for the 19 is smaller and lower. That's the sizing. That's how it is. Oh, and equals 2. I forgot that part. Everything's the same size except for the 19. Okay? So we look at problem number 11. You identify the base. This is the base, and this is the exponent. And so we should be able to write log base 225, and that exponent is 1/2, so it's going to equal 1/2. Log base 225 of 15 equals 1/2. 13, same thing. Rewrite the equation in logarithmic form. Log base 64 of 8 equals 1/2. Identify the base, identify the exponent. This is not so bad. 4 squared equals 16. What's the base? 4. Good job. Thank you. So log base 4. What's the exponent? Nope. Exponent is 2. There you go. So log base 4 of 16 equals 2. Now, one thing that's weird about logarithms is I think when we see an exponential, 4 squared equals 16 makes perfect sense to our brains, and we understand that. All right. 4 squared equals 16. 4 times 4 equals 16. I think that's easy to understand. But then when we see this, we don't recognize what it's saying, but it's saying the same thing. Okay, it's still saying the same thing. Log base 4 of 16 is equal to 2. Now, the hardest part is when we come to evaluating each expression. And at some point when you're good at this, and you realize, and it really sinks in that a logarithm is equal to an exponent, you'll be able to skip some steps and do some of these in your head. You're probably not there yet. All right, but log base 6 of 36 is easy once you know that the answer is the exponent. The answer is an exponent. All right, so if you don't know how to do this in your head, then let's do this. I'm going to say equals x. All right, so write that down. Write that down, equals x. And then let's just kind of transform it into the other kind of problem. Let's change the logarithm into an exponential like we did in one of the previous problem sets. What's the base in this statement? What's the base? 6, right? Log base 6. So the base is 6. And what's the exponent in this statement? X, because the logarithm equals the exponent. So 6 to the x equals 36. You can probably do that in your head. What must x equal? 6 to the 6th power? Nope. 6 to the what power? Second. This has to be a 2 right there. In order to make 36, that has to be 2. 6 to the 2nd power equals 36. If we were doing what we did yesterday, or what we did in the last lesson, we'd say, well, 36 is the same thing as 6 squared. So 6 to the x equals 6 squared. X must equal 2. That's my answer. Evaluate. Log base 6 of 36 is 2. It's just the exponent. So then 19 is a little bit harder, but it's still the same thing. I'm looking for the exponent that makes 32. I'm looking for the exponent that makes 32. If you think about it that way, you might be able to do it in your head. If you can't yet, that's okay. Write equals x, and then do it the same way as some of the other problems. I've got a base 2 with an exponent of x equal to 32. For some reason, that makes it a little bit easier to see what's happening in your head. Maybe you've got it. Maybe you know what x makes 32. 2 to the something power equals 32. Or if you do what we did in the last lesson, we could say, well, let's break down the 32. That's 2 divided by 2, you get 16. Divided by 2, you get 8. Divided by 2, you get 4. Divided by 2, you get 2. That's 2 to the 5th right there. So 2 to the x equals 2 to the 5th. X must equal 5. It's just the exponent. 2 to the 5th power equals 32. I'm finding the exponent that makes 32. So then the next one's hard because 243 is unfamiliar, but it's the same thing. You're looking for the exponent that's going to make 243. Anybody want to guess? 5? Good guess. I'm not sure if that's right, but maybe. All right, base 3 exponent x equals 243. Let's check it out. Okay. So what'd you say? 3 to the 5th? Yeah, that's right. 3 to the 5th power equals 243. I was thinking it was 3 to the 4th, but that's 81. So your answer's got to be 5. 243 is equal to 3 to the 5th power. 3 to the x equals 3 to the 5th. X must equal 5. That's your answer, 5. All right. Next one, a little bit easier because we're more familiar with a 4 and a 16. But think about it this way. What exponent will make 16? Might be able to do this one in your head. 2. Good. That's right. The answer is going to be 2. We can see this one. Sometimes you'll be able to see them. Sometimes you won't. But if you can't see it, you're going to say, all right, so base 4, exponent x, we're looking for what exponent is going to make 16. Maybe now it's clear. Or you can change the 16 into 4 squared. Maybe now it's clear. 4 to the x equals 4 to the second, x equals 2.